let's take a look at this particular subtopic. So as I said before, this subtopic is there's so many things to learn in this subtopic. Okay, but we started off by talking about resistance, how to calculate effective resistance, and then how to use Ohm's law. Okay, Ohm's law, the electric current is directly proportional to the potential difference if the temperature and other physical conditions are constant. So this is very similar to Hooke's law. Okay, because Hooke's law, dia ada syarat lagi tau. And so don't forget that Ohm's law, there is also a condition. Okay, syarat itu mesti termasuk di dalam Ohm's law. And then we learn the formula, which is V equals to IR. If we can calculate the effective resistance and we have the potential difference, we can calculate the current that is flowing through it. And so the first experiment that you did was an experiment, this one lah. Okay, the experiment to determine the, this one, to determine the relationship between potential difference and the current. And this experiment that you did on Tuesday, dia terbahagi kepada dua bahagian. Okay, there are two parts in this experiment. One is you use an ohmic conductor, and another one is you use a non-ohmic conductor. So an ohmic conductor is a conductor that follows Ohm's law. Okay, Ohm's law dia cakap current potential difference is directly proportional selagi temperature dan physical state is the same. A non-ohmic conductor will not follow Ohm's law. Okay, so conductor is anything yang boleh mengalir electricity lah. Okay, that's normal. Okay, and there are two types lah, which is ohmic conductor, okay, dan non-ohmic conductor. So this is how your graph should look like. Okay, the ohmic conductor should be a directly proportional graph, and the non-ohmic conductor, saya difahamkan kamu punya non-ohmic conductor kan, dia tidak boleh satu kaligus kau kasih kena semua. So yes, you still have to follow best fit lah. Make sure dia balance on both sides yang tidak kena. Tetapi yang paling penting adalah a non-ohmic conductor, we find that the the voltage, the potential difference, this is wrong, sorry people, ini silap ini. This is not supposed to be R. Okay, it's supposed to be V/V. Okay, reminder everybody, we are using this standard for the symbol and the unit. Okay, symbol of current is I for current. Okay, I also don't know why. Okay, and the unit for current is ampere. So I/A. Kita pakai slash lah. Okay, we will always use slash for all our this one. Okay, so we find that in the ohmic conductor is directly proportional. In the non-ohmic conductor, dia adalah increasing. Okay, this is the potential difference increases when the current increases. Tetapi dia bukan directly proportional. Okay, the larger the current, the larger the potential difference. Cuma dia bukan directly proportional. Okay, so you can take a screenshot of this precaution. I think this precaution is also inside your handout, right? Let me just double check. Oh, okay. So your handout, page 90 in your handout, this one. Okay, page 90, the precaution, these are the standard langkah berjaga-jaga when we do an electricity experiment. Okay, I'm actually a little bit sad lah, because you know why? Electricity experiment is so important, and it kind of sucks that we have to do this virtually lah. Okay, but I cannot wait anymore lah. Okay, I thought that we would be going back to school soon, tapi sekali tengok sambung lagi PKP, jadi I have no choice lah. We have to do this virtually, and then hopefully when we go back to school, if we ever go back to school, I will try to at least do one set with you so that you understand these precautions. Okay, number one, we make sure that the connecting wires are connected tightly. Number two, we avoid parallax error, okay, by making sure that the pointer and the image of the pointer in the mirror of the ammeter and the voltmeter is overlapped. Number three, and this is very important, we have to switch off the switch when we are taking, if we are not, astaga, not taking any reading, okay, so that the temperature of the conductor wire is constant. Please include these precautions in your experiment, okay, in your experiment report. I think it's good for you to write down so that you know when the time comes. Okay, what is the function of the rheostat in the circuit? It is to control the current that flows. Everything is actually inside here. Okay, the discussion session in your handout. Okay, saya cuma mau cakap pasal ini sajalah. Okay, then calculate the gradient. This is not required. Ini adakah diorang suruh kamu untuk kira gradient di dalam eksperimen? Did they ask you to calculate the gradient?
Tidak, dia suruh compare je.
Dia suruh compare saja kan? Okay, so this one maybe what you can do is you can do it for your handout lah. Okay, but maybe just to write sahaja, when you calculate the gradient, since it is V against I, okay, we find that according to Ohm's law formula is V equals to I times R. And so if I move the I across, I will get V over I equals to R. Right? And that's exactly what we're counting. In an ohmic conductor, when you calculate the gradient, you are actually calculating the resistance. Let me repeat this again. Bagi conductor ohm, okay, for a potential difference against current graph, when you calculate the gradient, you are actually calculating the resistance. Okay, Ohm's law experiment. Walaupun dalam eksperimen yang kamu buat pada hari Selasa lepas kan, sebenarnya you don't have to calculate the gradient, but I need you to know this piece of information lah. Okay, ini adalah maklumat untuk dipelajari. Okay, the gradient actually represents the resistance. Okay, so in the comparison, this comparison you can find in your textbook, okay, and you can also write this down. An ohmic conductor is a conductor which obeys Ohm's law. The shape of the graph will be a straight line through the origin, and we find that the current is directly proportional to the potential difference. And the fixed gradient, it has a fixed gradient, okay, which represents the resistance of the wire. Okay, and since the gradient is fixed, the resistance of the wire is also a fixed value. Dia punya resistance tidak berubah-ubah. And that is what makes it an ohmic conductor. Okay, an ohmic conductor, conductor ber-ohm is a conductor where the resistance is fixed, as opposed to a non-ohmic conductor. Because it does not obey Ohm's law, the shape of the graph is a curve. When I increases, potential difference increases, but the gradient also increases. Okay, which makes the resistance of the non-ohmic conductor increase. The bigger the current, the bigger the resistance for a non-ohmic conductor. Maksudnya dia punya gradient, dia punya resistance ini kan, the resistance of a non-ohmic conductor is not fixed. It is always changing. Okay, it's always increasing lah. The more current you put into it, the more the resistance increases. That's why it cannot follow Ohm's law, because Ohm's law, temperature and the state of the conductor must be fixed, and also the resistance. Okay, that's why they are directly proportional. So the biggest difference lah, okay, between an ohmic conductor and a non-ohmic conductor is the issue of the gradient, the issue of the resistance. Sorry. Okay, ohmic conductor resistance is fixed. Non-ohmic conductor, the resistance is not fixed. Okay, it is always increasing. What is the example of the ohmic conductor they gave in the experiment? What is the conductor they use? Anybody?
Constant wire.
It's a constant wire. Constant wire is a classic example of an ohmic conductor. What about the non-ohmic conductor? Apa dia pakai?
Bulb.
Bulb, okay. inside the bulb, what is the
Non-Ohmic.
conductor inside the bulb? Yeah, I know filament. I know it's filament, but what is the element? Apa unsur itu?
Tungsten.
Tungsten, okay, tungsten, Tungsten. So tungsten is a classic example of a non-ohmic conductor. Okay, dia punya resistance, makin banyak current kamu bekalkan, makin tinggi dia punya resistance. Which is why it is good as a light bulb. Okay, sebab dia boleh menghasilkan a big amount of heat lah. Okay, and also light. So if you can, okay, somewhere wherever lah in your notes, okay, just write down there lah. Example of ohmic and non-ohmic conductor. Ohmic conductor example is constantan, okay, and non-ohmic conductor an example is tungsten. Okay, there are many other types, okay, of ohmic conductor and non-ohmic conductor. You can do this research on your own lah. Actually, you can research to find out, okay, which is ohmic, which is non-ohmic. Okay. Then the next experiment you did was this one, right? The factors affecting the resistance. Which is the factor that you were, apa faktor yang kamu mengkaji itu? Experiment 3.3, is it? What is the factor that you were experimenting? Is it the length or the thickness of the wire or the material of the wire? Which one? Which is the factor that you were doing the experiment on?
Area.
Cross-sectional area. Oh ya, okay, betul. So Chris Fia yang sampai dia menangis mau bagi tahu saya, how ni SWG. Okay, so cross-sectional area was the experiment that you did. Okay, so you find that actually in experiment 3.1 and 3.3, and even in 3.2 lah, okay, look at the experimental setup. It's always the same tau. Okay, saya tengok balik, look at the experimental setup. It is always cell kering, okay, the dry cell connected to the rheostat, okay, the rheostat somewhere over here, and then there's a switch over here, there's an ammeter, and then there's a voltmeter, and then a constantan wire. Okay, sama saja. Even in the length experiment, which we didn't do lah, okay, the length experiment, the longer the length, the bigger the resistance, right? Okay, the longer the wire, the higher the resistance. Look at the setup. It is the same. Okay, you have the dry cell, you have the rheostat, the switch, ammeter, a constantan wire. Sorry, the constantan wire is not here. Constantan wire, okay, and then the voltmeter that is always parallel to the constantan wire. Okay, cuma yang berubah di sini adalah the manipulated variable is the length of the wire lah. So you have shorter wire, then you have longer wire. Okay, the responding variable will be the resistance, constant will be the diameter of the wire, etc., etc. So you will find that for the length of the wire, I will give you this handout so that you can copy down the values in the table lah. Okay, so that at least your notes can be complete. So in this experiment, what can be concluded? Astaga, ada animation lah bakula. Okay, is that it is directly proportional. Okay, so the conclusion is the length of the wire is directly proportional to the resistance of the wire. The longer the wire, the higher the resistance. Okay, directly proportional. So itu adalah eksperimen yang kamu tidak buat. I didn't ask you to do because I only asked you to do this one. Okay, the cross-sectional wire. Kita pakai dawai nipis dan kita pakai dawai tebal. Okay, and so your hypothesis is the larger the cross-sectional area of the wire, makin tebal itu wire, the lower the resistance. Okay, and so this same setup, look at the setup, always the same. Okay, cuma yang berubah in this experiment, yang berubah adalah ketebalan wire. You use a different thickness of the wire. Okay, and because this is physics, okay, we don't say thickness lah. Okay, we use a very canggih word which is called cross-sectional area. Okay, cross-sectional area is just a fancy word for thickness. Okay, it means the same thing, but cross-sectional area makes you sound much smarter. Okay, Nampak lebih pandai lah kalau kau pakai perkataan cross-sectional area. Okay, so same experiment, okay, except that dalam video yang kamu buat, you didn't get this reading lah. Okay, so I will share this reading with you so that you can fill it in your handout. This handout is in page 98. Yeah, okay, page 98. So everything is there. I will pass this to you later. Okay, and so you find that when you plot a graph of R against A, okay, you will get this kind of graph. Okay, but when you plot the graph of R against 1 over A, you will get a directly proportional graph. Which means that semakin besar ketebalan, the bigger your cross-sectional area, the lower your resistance. Okay, and we find this proof to be true. So what is represented by the value of SWG? SWG represents the diameter for each wire. Okay, I mentioned this in the class before the holidays lah. Okay, so the relationship between SWG, the larger the value of the SWG, the thinner the wire, dia terbalik. So the relationship is inversely proportional. Okay, and I hope that you got this kind of graph in your experiment. Sorry, I need to ask, dalam eksperimen kan, do you have to draw both or you only draw R against A?
R against A.
Sahaja.
Yes.
Sahaja, okay. All right, then this is, you can draw this in your notes lah. Okay. So this is the next one, experiment 3.4. Talking about the resistivity. Okay, so when you do this, we find that this is the value that another person did the experiment. I don't know whether it's the same as the value that you got from the video, but suffice to say that, look at these two types of wires. Both constantan and nichrome are ohmic conductors. Okay, this is the number one thing you need to know. Both constantan and nichrome are ohmic conductors. Mereka mematuhi hukum Ohm. Dia bukan macam tungsten. Okay, but we find that the resistivity is different. The resistance of nichrome wire is larger than the resistance of constantan wire. Okay, and so we find that there is this idea of this relationship between resistance and resistivity. Okay, every single wire has different resistivity. Okay, dia ada resistivity sendirilah. So because the resistance of nichrome wire is bigger than constantan wire, so we say that nichrome has a higher resistivity. Okay, dia punya kerintangan adalah lebih besar berbanding dengan constantan. Now, what is so important about this resistivity lah? Bilakah situasi di mana resistance yang tinggi adalah bagus, resistance yang rendah adalah tidak bagus? We actually talked about this in some class before the holidays lah. Okay, yeah, I know. I feel a little bit of regret that I have to split this subtopic into before holidays and after holidays. Sebab besar mungkin masa cuti, besar mungkin kamu sudah lupa bahkan. Okay, so please watch the previous video. Okay, the class before this lah. Okay, because I remember that in that class I talked about what situations where you want low resistance is good, what situations where you want high resistance is good. Okay, we use high resistance wires for things like cooking, oven, toaster. Ini semua we use high resistance wires. Okay, we use low resistance wires for other purposes lah. Okay, solving problems involving wire resistance. So we have calculate the total resistance for a roll of copper wire with length of 10 meters. Just to remind you, this is the formula, this is the formula for resistance. Okay, R equals to rho L over A, length over cross-sectional area. Okay, the rho over here is not density, okay, people, is resistivity. Okay, so in this question, we are given the resistivity of copper at 20 degrees Celsius is 1.72 times 10 to the power of negative 8. So the good news is resistivity is always given to you. The bad news is you have to make sure that the units are the same. Okay, and usually we use meter lah. Can somebody please change this 2 millimeter squared to meter squared? Okay, negative 6 is 2 to the power of 2 times 10 to the power of negative 6. Okay, milimeter kepada meter is bahagi 10 bahagi 100 bahkan. Tetapi oleh sebab dia adalah squared, you have to bahagi 10 dua kali, bahagi 100 dua kali. Okay, so you get 2 times 10 to the power of negative 6. So you substitute into the formula. Can you calculate the resistance, please? R equals to rho L over A. Oh, 8.6. 8.6 what? 8.6 only. 10 meters to 0.086. 0.086. So, Wilson, what happened? Why is it 8.6? Okay, rho L over A. You substitute correctly, you should get 0.086 ohms. Okay, I will forgive you for not being able to write the symbol for ohm. Okay, but never forget resistance, the unit is ohm. Okay, question number 2. For his wiring home, Ahmad bought a roll of aluminium wire that has a radius of 0.5 millimeter and length of 500 meters. Interesting. Okay, given the value of resistivity of aluminium at 20 degrees Celsius, what is the resistance? Formula is R equals to rho L over A. Okay, so given your rho is given, your L is given, how do I calculate the area? How do I calculate the area? I need to change the radius to area. Wire is circle bahkan. So the area, this is 0.5 millimeters. Millimeters, people, please change it to meter first before you calculate. Okay, so the area will be pi r squared. Okay, you have to calculate the area now. So pi r squared, but make sure that your r is 0.5, not millimeters, but change it to meters. Okay, 2 minutes. Calculate this and tell me the resistance, please. Okay, fine. 17.83 lah. Ini yang silap ini. Okay. Alright, 17.83. Sorry, I didn't do this calculation. So, okay. Coil of pure copper wire with a length of 500 meters and a radius of 0.5 millimeters. Okay, let's standardize this. 0.5 millimeters is 0.3 zeros. 0, 0, 5. Okay. Astaga, 0.0005. Okay, meters. Tapi dia sudah bagi resistance. Question is find the resistivity of copper. So this one is find the value of rho. Okay, can you try this please? 1.697, 1.696 times 10 to the power negative 8, is it? As long as it's 10 to the power negative, negative 6. It should be negative 8. Times 10 to the power negative 8 kan? Yeah, okay. So, okay, so Daniel, you wrote 1.7 kan? I would highly suggest that you write 3 decimal places, or you can be as extra as Wilson lah. Wilson write everything on his calculator. Also can lah. Okay, try not to round off to such a small decimal place. Because we are no longer in lower form. Usually higher form, the more decimal places, the better lah. Rather than just one decimal place. Okay, Daniel? All right, last question. Last question, and then I got something that I'm very excited to show you. That's why today my class is like so out of this world. Tapi kita cuba sajalah. Okay, current flows through the wire, through a zinc wire of length 1 millimeter. Okay, the length is 1 millimeter, okay, and it's 1 ampere. Okay, calculate the resistance of the wire. Resistivity is here. The value of the potential difference is voltage. So you are thinking of, the V equals to IR. Okay, V equals to I times R formula. You already have the current. You find the resistance from question A, you should be able to get question B. Okay, give this a try.
Kosong 0.1715 ohm.
0.1715 ohm. What happened? Ini kenapa ini? Kenapa ada pi di sini? Why is there a pi over here?
Mau cari area.
Tapi dia tidak bagi dia punya.
In
Oh
the
my
paper
goodness.
ada.
In the
handout.
paper ada. Diameter of one. Oh, okay. Tapi kau tengok. Betul pula dia punya design sekarang. Oh, okay. In the paper ada. Sorry Crispia, what's your answer? How come your answer is so besarnya beza daripada ini? Berapa jawapan kamu tadi?
Oh,
Aduh.
jap.
Jap, ya.
Jap. Oh, jap.
Okay, jap. Even the L also is wrong, right? 1 millimeter. It should be 0.001, right?
In the paper, it's 1 meter.
You're annoying, gadis. Okay, everyone, follow the paper. Don't follow this slide. Oh no, okay. I think I must have been sleeping when I was doing this slide. Okay, sorry everyone. Follow the paper lah. So it's 1 meter, the diameter is 1 millimeter. Saya rasakan dia tercut di sini kan. Macam kena censorship di sana itu. So is it really 0.7, Irdina?
Betul. Dah dapat 0.7.
Okay. Betul. Alright, so the value of the potential difference will be also 0.7 volts lah. Okay, so this is where we combine both the formulas that we learned in this subtopic. Okay, which is just V equals to IR and then the resistance and resistivity formula. Okay, 0.70. Okay, so your homework for this weekend, this very long and wonderful weekend, is to finish everything in tutorial 3.2. All the way from page 103, and every question that we haven't answered lah. Yang I know that we have answered a few questions, if I'm not mistaken. Okay, tapi mana-mana yang kita belum jawab, 103 all the way to 109. Okay, yeah, there's a lot of questions lah.